So traditionally, most of you guys probably feel like you're not as adequate with asynchronous programming, right? So today we're going to talk about that, and we're going to start off kind of in a weird spot, not really with async and await. And to be fair, we're going to be coding together. So this is going to be a very interactive session. If you have a laptop, please follow along, because we're going to be talking in a very interesting way. So first off, let's talk about why we do asynchronous, right? And then we're going to talk about callbacks and why we have callbacks and why callbacks kind of didn't work for us and why we have promises, and then lastly, why we have async and await. So that's kind of our journey that we're going to be doing today. So I'm going to go straight into code. Yeah. So let me ask you a question. What is a callback to you guys? Someone blurb it out. What does a callback mean?
Do work after you're done doing something else.
Okay, do work after you're done doing something else. Anyone else? Come on, don't be shy. Ditto, okay. And it's true. We get a response back when something is done, right? Now, it's a little bit more to that in JavaScript. It has to do with the function itself, and the first parameter is an error. Now, not everyone actually adheres to that, and I could show a few frameworks that don't. But for the most part in JavaScript, with a callback function, the first parameter is an error, right? And we do that because that's how we decided that callbacks will work. And I used to be a C# developer back in the day, and this concept was very weird to me, because I'm like, I don't understand where we're starting out and what we're doing exactly. And so it was not for a long time that I actually understood, hey, a callback is just a function, and the first parameter in the function is an error. So let's actually write a variable called callback. You guys see that? Okay, so we're going to, can you hear me okay? Okay. This? Bam. Let's make a variable called callback, okay? And we'll use an arrow function just because those are the bee's knees right now. And this is really what a callback looks like. It's a function that has an error as its first parameter. Now, a callback can have more parameters down the road, like if you want to pass data back to it. But by default, it's an error. That's the first parameter that we have. And traditionally, when we're writing a callback function, what happens? We have some code that goes like this, right? Do something awesome with the error, like rethrow the error. I mean, that's not very pragmatic, but it kind of explains how code looks like with a callback. And then you might do some more work down here, right? So that's typically what a callback looks like. The purpose of it is to tell us when the work is done doing something else, fetching data from a database, right? And this callback is just a function, which is super weird in JavaScript. If you come from C# or Java or any other language, a function isn't a data type, so that's super weird, right? And so we end up with this concept that's more or less foreign to people who transition over to JavaScript, and it's such a fundamental piece. So what does this look like if we were to simulate something? Let's say we were going to call this fetch data, right? How do we use callbacks? Well, because callbacks are just a type of function, we can pass them into our function, fetch data here, and then when we're done fetching data, we can tell the callback that we're done fetching data, right? And so whatever fetch data or whatever fetch data does, eventually when we're done, we're going to say callback, right? And more or less what that does is it says, hey, I'm done with fetching data, because up here we're gonna call some sort of API, right? We're gonna fetch data, and then at the end of it we're gonna say, hey, I'm done. That's what the callback does. And for some reason it's a weird concept for a lot of beginners to understand, and I feel you, because it took a while for me to understand that. Now, the weird part is that how does this tie into promises, right? So not only in JavaScript do we require you to know what a callback is, but then all of a sudden, if you do callbacks, you're doing this thing that we call callback hell, right? We've all seen this. You've seen code like this before? You've written code like that before. Very good. It's hard to read, right? And I call it the cone of shame, because there's this cone going on, right? And it's something that the community, when we had callbacks, that's more or less how they wanted callbacks to work, right? And they decided, hey, this is kind of unwieldy, right? And so the next thing they did is they said, well, there's this awesome thing called a promise, right? And a promise more or less does the same thing. It's just a little different. What's interesting about a promise is it's just a glorified callback. That's something that I didn't have an aha moment until recently, where I was using the promise constructor and I was passing in a function. I'm like, holy cow, that is just a callback with 2 parameters, right? So let's dive into that a little bit more. So if you've written callback hill code, which we all have, right? Eventually we arrive at the spot where we deal with something that has to do with a promise, right? And can someone tell me what a promise is different from a callback? Is there any difference, or what's the differences? You can speak. Does anyone know what the difference is between a callback and a promise? Promise is an object. Yep, and it has a function on it, an object that has a function with then and catch, right? And the difference between a callback and a promise is we don't have to write all of that code to check if there's an error or not. If there's something that happens in a promise somewhere, it's going to call the catch function, which more or less is our error handling, right? And so if we were to refactor our fetch data to use a promise-driven approach, we would call underneath fetch data, there would be a then clause. Let me actually implement fetch data so it's not ticked off at me. And let's just make it do something kind of weird where we just return back an empty array. So promise is an interesting object, by the way. There's a capital P promise, which is more or less like a static function, and it has a catch and it has a resolve. And more or less what those do is they streamline the promise chain. So they let us pass a value and it'll wrap it in a promise. Now I want you to keep a hold of that, because we're going to get back to that here in a second when we get to async and await. Because what we're going to find out is that async is just syntactic sugar over that. But this capital P promise, when I'm instructing, I call it the capital P promise function, is more or less just a shortcut around how to build a promise object. Because sometimes you just need to pass a value back with a promise. You don't need to do anything crazy with it. So capital P promise.resolve helps you do that, so that you don't have to wrap it in a constructor. And we'll deal with that here in a second. So what we can do is make it resolve back with an array, right? And then when we call fetch data, underneath it we say then, and that then function is more or less a callback. If you think about it, it's just the callback without the error, right? So we put a function inside of here. We'll probably capture some sort of results or something like that, and then we'll do stuff, right? That's kind of what a promise looks like. And it's a little bit weird for people who are starting out, because that's kind of awkward, right? It's not something that we're used to. If you come from a C# and Java background and you have a very, I hate to use the term synchronous, but more like serial from top to bottom language, this whole feeling around JavaScript feels weird, because it's not a top-down, top-to-bottom language, right? It's built around this thing called the event loop, and there's this mystical thing going on behind the scenes, but what it means is that JavaScript knows how to multitask very well. And this whole promise chain that we're dealing with right here is its way of dealing with multitasking, right? Because it can do something well and then let you know when you're done. And that's all a promise is, it lets you know when you're done. At the end of it, you should always catch errors, right? And handle them that way. So this is what a promise-based fetch data looks like. It's a little different, right? And what it did is it made it so that, and I like this talk because there's actually a promise hell that can happen where you more or less are doing this fetch book code right here, right? And then you're doing something with book, and then you're formatting book, and you're returning the format book function, and that has a then, right? I think we've all written this type of code also. And what the author more or less suggests is, well, just keep on nesting thens on top of each other. Because that's what a promise is. It's a object with then and catch that's returned back every time, right? And that's kind of weird and meta, but more or less what we can do with that is we can keep on chaining stuff together, and we can keep on doing stuff such that it can let us know when we're done with stuff, right? And we can more or less make it so that, see, the reason that we have the event loop is more or less because we didn't want to implement threading in JavaScript, right? And that's kind of a deep topic, but at the end of the day, what we're trying to do here is say, hey, just let me know when you're done. When you're done, I'm going to do something, and then if I'm going to do another thing, I'm going to let you tell me when you're done, right? Like that's the whole purpose behind promises. Okay, so that's cool. Right now, this code's pretty lame because it's not really doing anything. How about we switch over to something that's a little bit more cool? Like, for example, let's talk about senators here for a second. So let's bring this down into something that's a little bit more real world and a little bit more useful, because we've been talking kind of metaphorically. Okay, so the first thing that we notice when we're dealing with asynchronous code with the async await pattern, anyone know what's the first thing that pops out to you if we're highlighting line 5? What's the new keyword that's in there? The async keyword, right? The async keyword is new, right? And the rule of thumb with async usually is, and this doesn't always hold true, so I'm going to put this in air quotes, that when you have an async, you should have an accompanying await, usually. Now, I put that in air quotes because I'm going to show you that that doesn't actually matter. But for now, in our world of thinking, if you see an async keyword, you should see an accompanying await. What do you guys think's going on there? What do you think's happening underneath the hood? Say what? We're wrapping a promise. Honestly, that's all that's going on. We're wrapping a simple promise using promise.resolve. It's more or less just a way to think about writing code that's more synchronous, right? And you have to say synchronous, but more serial from top to bottom. And when we see the keyword await, we're more or less saying, hey, wait, not await, but wait until you get a response back from this thing, and that thing is a promise. So let's shift back here for a second. So when we retrieve data from a promise, we're waiting for the then function to be called, right? When we await a promise, what's really happening is it's calling the then function, and whatever it gets from the then function, it's giving us the value back. And that's really all await is doing for us. It's waiting for the response of the then to be handled. What happens if there's an error? Does anyone know what happens if an error happens with an await? I hear whispers. An exception's thrown, right? Yeah, an exception's thrown. And so what do we do with that, right? And that kind of depends on what you're doing, honestly. So most of the time you're going to wrap your code in a try-catch, right? And you're going to more or less catch the exception and then handle it appropriately, whatever that case is. It'll come up, hopefully, maybe. Okay, cool. And we're back. Okay, so let's go back to promises for a second, because there's something that I want to point out. Okay, so what if you're dealing with, so this is a personal, this is a thought that I have, right? Like more or less this is my opinion, but I feel like most of the code that you write nowadays should be more or less wrapped in a promise. Now, the people that care about more or less speed and stuff like that, they'll probably argue with me, well, promises add on some time and promises add on some processing, right? But if you think about it, can you really measure that from whoever is using your code? I bet you that you can't. I bet you that the amount of time that it takes to actually implement the promise versus to just wrap it in a promise versus to not probably will be minimal, right? And so what a promise wrapped thing gives you is it gives you a standard way of accessing information, right? So let's look at something interesting. So I'm going to make a new file here, and we're going to call this. We'll come back to our senators here in a second, but I'm going to call this the calculator. Okay. And what I want to do here is I want to talk about what we normally write when we're writing something like an add function where we have x and y, right? And then we just return back x plus y. What's harmful about this is that it's not wrapped in a promise, right? Sorry. Yeah, so that code right there is a little bit harmful. Mainly because it's actually blocking execution in JavaScript. To a beginner, that's mystical, and you don't understand why that's happening, but that's kind of what's happening underneath the hood. Because even though addition is happening and it's relatively quick, it still takes processing time. And even though that processing time is minute and probably minimal, and if you were to argue, well, it's probably, if you just return that back, you're probably not going to see any difference between a promise. What it does is as you start applying more operations on top of it, and you're not letting the event loop do its thing, you could actually block information, especially if you're doing something that's super mathematical, right? So one thing that's interesting about when we get into the async await pattern is we denote functions that are asynchronous by the async keyword. So think about that as a developer. You now can look at this function and tell that it is an asynchronous function by the keyword. You can see that when you're reading that. You don't need to dive into the documentation of a function. You can see that function is asynchronous. That's a benefit. The other thing that's going on is underneath the hood, it's doing this for me. By putting that async in front of the function there, it's wrapping the addition in promise.resolve. Let me prove that out to you. Let me go back to my scratch pad over here. So let me copy this code here and come back into here, and let's re-implement this. So we got our add function here. So notice that if I say add.then, let's see if it'll log out here. Maybe it won't. Come on. Do what? Oh yeah, thanks. In fact, let's remove that because that's what I want to prove out. So add.then, okay? Might not actually show that, but here, let me prove that out to you this way. Log. Okay. Log's having issues. I'm using this new tool called Chuoka. It's super awesome, but sometimes it has issues. Well, that's just fun, right? So more or less, the async keyword. So let's put an await in front of this and see what happens. And it's weird because we're getting a result here, but it's just not showing out the addition here. Anyone have any ideas? Passing the parameters, very good. we're not getting a result back because we're not passing anything in, right? Now let's take away this await and see what happens. What happened? Nothing. Because what's going on is underneath the hood, its await is more or less, or by declaring it as async, is more or less wrapping this thing in a promise.resolve. This is exactly what's happening underneath the hood, right? But we don't have to put all that stuff in. Now, as a beginner, that may not look cool, but if you've been around the block a couple of times, wrapping everything in a promise.resolve or putting it in a promise is kind of, it kind of stinks because you got to write all this boilerplate code, right? Now, what happens if I want to, let's keep our add function here. Let's add another one, maybe like subtract, right? Like a type. Wow, sorry. Actually, let's do multiply because there's a problem with subtract. Okay, and then let's actually make a function here. We're going to call it run. And the reason that we're going to do this is I want to show you what happens when you await something inside of an asynchronous function. So let's say async, right? And then down here, I'm just going to call my run function. And more or less inside of here, what I want to do is say add result, and then I want to say await, add, and then say 1, 2, or 3, it doesn't matter. And then I'm going to more or less write that out, and then I want to say multiply result. Okay, and then write out mult result. And sorry that it's not highlighting, but that's just QOCA or whatever. So think about this for a second. You're in a different language besides JavaScript. You're writing .NET or you're writing Java, and you've made a method or you've made something that executes code, right? Typically, when you're inside of a method, you operate from top to bottom, right? You're more or less you're executing from top to bottom, and this code now feels a lot more like what you would get from a Java or a C# perspective. It operates from top to bottom, and it waits until that function is done. Right? It waits until more or less the add and the multiply are done. So more or less all async and await is a syntactic sugar on top of a promise. Right? Anyone have a question about that? You guys are super quiet. Yeah.
So in C#, I can take the result of add 1, 2 and store that off in a variable, and then take the result of multiply 1, 4, store that off in a variable, and then later on await the result. Can you do that similarly here in the JavaScript await?
So
instead of awaiting add, can I just do add result equals add, and then later on await add result?
if you do that, it won't wait for the promise to happen. So the await more or less says wait until that thing is done. Well, I think what you're asking is more or less how do we parallelize that process? Yeah, right? That's a good question. So does anyone know how we parallelize a promise? Promise.all, very good. Promise.all is how we parallelize a process that more or less says, hey, I don't care about when these processes are done. I just want the processes to happen at some point in time and then give me a spot to more or less gather all of the results and do something with them. So let's practice that. So using our capital P promise.all, it takes an array of promises, right? So which more or less, because of how these things work, we can remove the await there because we don't actually want it to await. And here we can say results, and we can await that whole promise.all. And notice that now we get a parallelized process. So that's useful when you got to go do multiple things like, hey, I need to access the database, and maybe by I'm accessing the database, I need to do something else, but it's not really, they're not chained together, or they're not more or less like required for both to happen one before the other. promise.all helps us out. Okay, who's had to take code like this, if we have a promise and you've had a callback and you've had to use the promise constructor? Has anyone had to do that in here? Fun stuff, right? I want to point this out because this is the aha moment that I had personally. So typically we have a function inside of the promise constructor that has a resolve and a reject. And then inside here we do stuff. And I like to call the code on line 3 a lowercase p promise versus an uppercase p promise. And what that really means is line 3 is an instance. So because we're instantiating this promise object and passing it a function inside of its constructor, it's more or less, if you think about it, it's more or less a callback, but with its parameters reversed, right? Look, we got this resolve parameter and we got this reject parameter. And if you think about it, if we were to rip this out to a variable up here and call this, they call it an executor, and just make a variable up here that's a function, it's more or less a reversed callback. And that was interesting as I thought about that, because I was thinking about where's the tie-in between a callback and a promise, right? How do we make that happen? Or how did they jump from a callback to a promise? Because I always wondered how, the people who wrote JavaScript jumped from a callback to a promise. It more or less, I was playing around with this promise constructor one day and I saw that, wow, this is just a callback with reversed parameters. And what it does is if I'm doing work in here and then I'm done doing work, you return a resolve and then you can pass back whatever you're doing, right? And then up here, if you have an error, I like to always return back the function call because it reads easier to me. You don't have to do that. I could just say, if something like 1 equals 2, triple equals 2, right? Then that's an error, and we're going to reject that. But what this code does is it more, man, I cannot type. That's what happens when you're short. Sorry, I like to make short jokes. And more or less what it is it gives you control over when this promise resolves itself, right? Because that's really all a callback was it was a function that said, hey, I'm done doing something. And we agreed on the first parameter being an error. And then whatever data needed to come through came through. But inside of a promise, we get that exact same control if we use the promise constructor. Now, why is this important? Well, typically you may run into, and if you're using the Node API specifically, all of their API is implemented with callbacks. And luckily in the new release, they've given us utility to permissify or to change callback-based code into a promise, which is nice. Like, thank you. We've needed that for a while. But what was really going on was more or less they were saying, hey, like callbacks and promises, this is how they're related because this function resolves the code that's happening. So I thought that was super interesting. As I was studying promises, this was my aha moment. And I always wondered, like, how did they come up with this particular promise object? And what it was is I think that they made this constructor and they said, hey, look, like, here's, if you want to actually make a promise and not use the capital P promise.resolve or the capital P promise.catch, or reject, sorry, more or less, this is how you have to create a promise. Okay? And this object, if we were to come down here and look at promise, notice that it has a then, just like normal, and there's also a catch. I don't know if it's going to write that out, but so that was interesting to me. So the last thing that I want to point out, more or less, is just patterns and practices, right? Like, we've showed promise.all, and that's cool and exciting. What other types of patterns and practices do we use when we're using the async and await pattern? I'm gonna go back over to my project that I had over here. And I happened to pull down this API, which has a bunch of data in it about the current representatives in the government. I thought that would be kind of fun to play around with. And then I also have some for the senators, which we're gonna look at right now. Now I'm going to just write out this objects here so you guys can see the objects. Maybe. Let's see, where's my... Which, by the way, I'll post up this code so you guys can play around with it later. If you want to see kind of what type of things are going on. So let me just grab one of these and look at it in a single space here. So this particular API emits out a ton of different information. And I wanted to talk about one of the patterns that I use on a daily basis with it. I'm just gonna paste this out and then comment it out. Just give me 1 sec, and then I'll go back in presentation mode. By the way, when does this end again? I just want to make sure I'm okay on time. Okay, cool. All right, so this is what a object looks like from this API that I'm grabbing. And so something that we do sometimes is we hit an API, like I have above, and we need to filter stuff down, right? And when we do that, there's some things that kind of can catch you in a weird space if you're not careful. And I wanted to point a couple of those things out. First off, just looking at the different types of functions I have here, you can see that I have some discerning information that filters down the results of this API. So more or less, I have one that grabs all of the senators, and then I have another one that is more or less filtering out Republicans, right? And then one that filters out Democrats. And one of the things that kind of happens that is interesting is as you're doing your await here, if I were to kind of comment this out and then rewrite this, what happens is we get into the space where, okay, I need to grab, so we could write this function in a one-line function and simplify it a little bit. The reason that I broke it out into a variable was because sometimes it's easier to see when you're talking through some things, but like we could make this function a one-liner. But when we do that, we actually run into a problem. And the problem that we run into is we'll come here and we'll say await all, and then I'm gonna call .filter on here, and then I'm going to filter it out by party, just like I got down here, and notice that my test framework is yelling at me. So can anyone deduce what's going on here and why it's giving that error? I think someone said it. Say it louder. No? I heard it, I think. So yeah, it's not, you have a chicken and egg issue going on right here. So what has to happen is order of operations, right? So it's awaiting the filter, but the filter is supposed to happen after I actually await for the data, right? So this is a classical kind of pattern that happens where more or less it's order of operations. Oops, sorry. By wrapping that inside of parentheses there, I've now used more or less math to say, hey, do this await first, and then when you're done with it, do the filter, right? And that catches people off guard all the time because they're like, what? Why isn't this working? And so let's kind of look at that error again, because it's not really apparent if you're reading the error. The all.filter is not a function. That doesn't really tell you what's going on, right? It's not very explanatory of more or less what the problem is. And so as a beginner, that's kind of hard to digest, right? And that's hard to understand what the problem is. And really all the problem is order of operations. Now, the reason that I wrote the initial code below with a variable also is because though this is maybe more or less sexier, it's kind of hard to read also, right? So, it just depends on what you're trying to do and if that makes sense or not, whether or not that's a better solution or practice, right? Sometimes I feel like writing the line on line 14 is sufficient and it gets the job done. If I'm working with people who maybe don't know that order of operations, the line below with the Democrats looks a little bit more readable to them. Again, just want to point out that the code is now reading from top to bottom, right? You're literally reading the code from line 23 to line 26 using the async keyword. You know that it's an asynchronous function. Using the await keyword, you know that you're going to wait for that all piece to come back, right? And it's not going to go down to line 27 until this senator's, if I could spell, I'm really bad at spelling. It's going to wait until that senator's variable is resolved. Underneath the hood, if we were to comment out, like if we were to call senators without awaiting, we were to log this out, I'm not sure how that's going to look, but notice that the all function that's an asynchronous function is still just a promise at the end of the day. So async await is just a glorified way of doing promises, more or less. That was my aha moment. Now, one thing that makes async and await kind of awesome and I used to be a .NET developer, so I empathize with the .NET developers, although I honestly really love JavaScript. But one of the things that was interesting about in .NET is how they did their async await. And anyone who doesn't know about it, more or less you had to write, so you would use an async function just like we have in JavaScript, but then underneath you had to use this task object. And the task object more or less wrapped around some sort of function or some sort of thing that it needed to do synchronously. And if you didn't do that, then you're going to have problems, right? And really, I thought how JavaScript did this was super elegant. We don't ever have to wrap anything with promise.resolve. It just does it itself. Even if we have a function, okay, that more or less is a hello world, right? And we mark it as async, and we say hello world, right? Like that's going to wrap it in a promise.resolve. And that is going to be a promise-based function. When I execute this function, if I didn't put two consts there, if I execute this function and we logged it out, it's still a promise, right? And so that's more or less what async and await brought to us. It was a very, very, like to me, it was one of the most exciting features of 2017, and I was waiting for it since 2015, but 2017 was awesome because it more or less solidified that pattern. And that pattern was fun because as a developer, I got back to kind of reading code in a more linear fashion. Now, what happens if, let's just do one thing here. What happens if hello world is a function that's malicious and throws an error, okay? And down here, let's say Republicans do some stuff with that. So we're going to await this hello world, and it's going to throw an error, right? And at the end of the day, you can still resolve that error using the catch function with the promise, right? One thing that people do, and it's more or less, it's kind of scary because you're swallowing errors, is they'll wrap all of their awaits in this whole try-catch piece business here. So you'll see beginners put a bunch of code like this because they want to make sure that they've caught that error and they're going to do something with it, right? Why do you think that try-catch right there is harmful? Yeah, it doesn't, notice that it doesn't prevent the code from executing. And what if this error was actually something that should do that? I guess that's a better question. So what I've effectively done is I've swallowed that exception. that's happened, right? And inside here, if we were to log this out, it would more or less be my oh no that I have above, but according to whatever program is executing this, browser, node, whatever, it has no idea that an error happened. Maybe that's what you want, right? But chances are maybe you don't want that to happen. Maybe this error prevents someone to be logged in or something like that. Now I've just more or less hidden it in the bowels of JavaScript. So having your try catch at the proper space is important. Another thing that happens is as we get into React land, right? That one's always interesting because when we use the more functional approaches with grabbing data and with Redux and all of that stuff, we sometimes have this weird space where we need to more or less wait for data to come back from somewhere, and then we are using Redux to mess around with that. And what I've found is that sometimes the async await pattern is kind of lost in there, and we have to use other libraries to resolve those promises. And I hope someday someone makes a more better version of the async await pattern in Redux, because I think that sometimes we lose that. Now, there's a promise library out there that we can await, but sometimes I feel like we're always kind of doing this, are we done yet? With Redux, right? And we've lost some of those pieces. Yeah, any other questions? I have one more piece, but go ahead. Mm-hmm. Mm-hmm. Yeah, so that's a very interesting question. Let me see if I can simulate that for you here. So let's imagine that we have, if you, I'll ask if this is what you're thinking in case I don't get it exactly, but let's say we have a loading variable false, right? Maybe somewhere, does that seem appropriate? Okay, and so the question more or less is, inside of our code here, I think what you're asking is how do we make sure that loading stops at the appropriate place, right? That's kind of something that I think eludes us sometimes. And one thing that you can keep in mind is, let me put the loading up in the all section, just because I don't want to screw around with filter. But hold on. Doop. Okay, so one strategy I've done in React is, we can still call then, right? Or I can await. I can await this get here and then just set it to loading. Or I guess you say loading true before. And then afterwards loading is false, right? Because the load, and it has to be a let. Sorry, I have habits of making everything a const, but the loading will be true before it gets data, right? And then when you're done, you can set it back to loading false. Is that kind of what you're asking? Oh, like you're in between fulfilled? So like you're in flight? Probably not with the async await pattern. Maybe Corey might have an idea. He's super smart. That works too. Yeah, it's a good question. Any other questions? Yeah. Uh-huh. more or less the try catch when you're using async is kind of the replacement for the .catch if you're using the asynchronous keyword. Other than that, it's more or less functionally the same, and you still deal with the similar problems, I think, like you're alluding to, where when you're talking about promises and you're catching things, the biggest thing to be aware of is what error am I trying to prevent and why, right? That's kind of the biggest question. And so the try catch won't actually solve that problem, because it's more or less just saying, hey, instead of being a more chainable syntax, we're going to use a then or a try and a catch, right? Whereas a promise is more chainable, right? At the very end, you'll have a catch, but it still doesn't fix your problem of knowing when you should do that, if that makes sense. But it's something to be aware of as a beginner, because when you learn things like React and you learn things in JavaScript, I've noticed that beginners get super excited about components and then they make everything a component, right? And so there's a fine line between making components that are useful and then just componentizing everything. And so it's important to be aware of why you're doing what you're doing. And then more or less, once you're aware of that, I think that self-awareness helps you write better code, right? And then just being aware of that stuff. Any other questions? All right. Thank you, guys. Appreciate it.